Hey everyone, good evening. Welcome to Developer Donuts, Dev and DevOps Pals Forever. Before we start, let me introduce you to our sponsors. Devtron is an open source platform which is democratizing the adoption of DevOps practices on Kubernetes. You can find their website links in the description box of this YouTube video or same in the live chat. It will be pasted in live chat. You can go and you can also visit their GitHub repo and start the repo. Coming back to today's meetup, today we have two sessions lined up for you. In the first session, we will gain an understanding about basic tenets of DevOps principle and how they can be applied for decision making in different situations. But that's not all. We have also arranged a fun live quiz for you at the end of the meetup. The winners will receive gift vouchers worth 200 INR, and you can find the registration link in the description box, and also it will be pasted in the live chat. You can register yourselves for free. And all right, without any further delay, I'll introduce our first speaker, Prashant Gildial. He's the co-founder and CEO of Devtron Labs.
Thanks, Karthik.
Hey
Hi, everyone.
Prashant. Hi.
Good to be
So,
here.
yes, could you please tell us little about yourself and the topic that you are going to present today?
Sure. Uh, so, I am Prashant. I am co-founder of Defcon Labs, which is an open source product which we have built to democratize the adoption of Kubernetes. So, throughout our journey as DevOps engineers, as developers, as head of technologies, we have seen certain gaps which are there in the DevOps tools which are present in the market. We have seen people struggling with them because there are multiple tools which are working across different verticals. How to bring them together is a big concern which people are trying to solve today. And that's where our product is aimed and solving it specifically for the Kubernetes. So that's what we are trying to achieve with this product. And thank you all. And I'm going to talk more about some of the principles which you can use whenever you are thinking of doing a DevOps related work, right? So any objective that you want to achieve, what are the main principles that you should be using to sort of achieve that particular task? That's what I'm going to be covering. I'll also take certain examples from DevCon specifically to tell you like how we applied the same principle in a particular situation, and that's how we created the particular product. So that's what we are going to do in the today's session. It's not going to be a hands-on session, but this is a session which will allow you to sort of think through any of the problems that you might be facing while taking up a DevOps related task. So with that, Karthik, can I start?
Yes, could you please share your screen?
Yeah, perfect. Right. So as I said, the topic of this presentation is thinking DevOps from the first principle. And I'm gonna give you a brief background of how DevOps came to be. I think most of you know that earlier DevOps was a huge Dev and Ops were like two different things, and that was creating a huge problem. There was a complete kind of a dark age where these two systems existed in isolation. They were not actually talking to each other. They knew of each other's existence, but there was no path from Dev to Ops, and it was creating huge problems, right? And that's what we keep on hearing. And I think most of you who are like very young in age might not have seen that particular time, but I have seen that time, right? So I have been of the pre-DevOps era. I have seen that time where developers would sort of put things together and hand it over, and they would not know what is going to happen with that particular package that they have provided. And the ops team might also not know what they have been given. They just have certain instructions which they try to execute and hoping that things would work, right? Now it may seem like during that time things were like very chaotic and things were bad, but I think we are only looking at a half picture when we look at it, right? Because at that time the complexity of the systems were also not as they are as it is today, right? So if you look at the microcosm and the macrocosm, so today also when a startup starts, right, they don't have a lot of customers. They would not be setting up the best practices of DevOps on day zero. Why? Because nobody cares if the website goes down, What they care more about is everybody who is in the company is focused more towards creating the competitive advantage, right? That is how things work. And as company becomes bigger and bigger, and there are more impacts that the company is creating, they are investing more and more into the DevOps principle. That's how things work. Same thing was happening earlier, where when the internet was not that in vogue, companies had very few customers, very few people were using internet. That's why they didn't care much about it. It was just working fine for them. Even if it was down for some time, nobody cared, because any which ways users might be taking a minute to download the page, right? But as things started evolving, people realized that this is something which cannot work. And so in 2007, people tried to figure out that now that the complexity is increasing, what can we do to sort of make things better than what they are currently? And this is sort of the hypothesis that they came with, right? So they said that for this bridge, to create a bridge between development and the ops side of it, what we need are like four pillars. First pillar is culture, right? So wherein we are saying that because you are trying to attempt something which has never been attempted before, two different streams which don't talk to each other in terms of their domain knowledge. It's not that they are not talking at all, but they don't understand each other's domain knowledge, right? Now they are coming together to do something different. Then you need to have a right culture where you are not finger pointing. You're not trying to sort of put a blame on somebody else and saying, oh, this is not my fault, they didn't say or they didn't do, right? So that was one of the most important things they believed we need to have if we want this change to happen. Today we take it for granted, where none of the companies have this kind of culture, right? Second thing for them was people. Again, because there are two different set of people who are coming together, it becomes very, very important that these people are good with the teamwork, right? So the focus should be on making the life of those people better. It should not be on just creating something, but how it is going to benefit those people. So the teamwork and collaboration would be very, very important to make it work. So people was the second thing that they focused on. The third thing was process, right? Because if you don't have any process and anybody is doing anything, you can't figure out what is working, what is not working. You can't iterate on it. You can't make it better. So that's why the third pillar became the process, that you need to define how things should happen, and so that you can iterate over it and keep on making it better. And the fourth thing was tools, which was kind of in a way encompassing all three of these things, right? Because tools is something which sort of enables you to have better DevOps practices by focusing on culture, people, and process, right? And during that time, again, if you look back, during that time, these tools were non existent. People had to create these tools, right? And that is why at that particular point of time, the emphasis was not given that much to tools. The emphasis was given more to culture, people, and process, because those were the things that they could fix. Tools were not something that they could fix overnight. They knew that it's going to take long amount of time for people to sort of experiment with it and figure out what are the right tools. But still they knew that tools are going to be the critical base of this DevOps paradigm shift which is happening, right? And uh, even though they had the pillars, the problem was that they were very, very broad based, right? So anybody can interpret that in any way. Oh, I have to do something with culture, it can be anything. I want to do something with people, it can be anything, right? So they said that then they came up with a framework wherein they provided certain guidances as to what are the important parameters, which sort of helps company achieve good DevOps practices to make sure that this delay can be reduced, this uh, problem with the releases can be reduced, right? And they said that for these particular things, it's called CALMS, CALMS. Again, I don't see a lot of people in the startup world talking about it today. This has become kind of ingrained in how we do things. But it is more at a, what I see is still that it is more at a senior management level, and it doesn't sort of populate down to the people who are actually executing things, right? But so this framework had like culture, again, what we already talked about, then automation. So the idea is whenever you are involving a human in the process, there are chances that things may go wrong. He may forget something, or they may not know about the complete things. They are not available right now, right? So that's why they thought that automation is one of the important components. Then another thing was the lean, because you have to do a lot of experiments. You don't know what is the right way to do things. So lean became very, very important, because you might be creating a year long roadmap, and then you may reach at a place which is like entirely wrong, right? So how do you do quicker and shorter iterations and keep on becoming better? That was the lean. Then the other thing is measurement, right? Because if you're doing something, how do you know you are becoming better? Maybe you are not becoming better at all, right? So you need to know what are the things that you are doing which is actually making your process better. And for that, it's important that you measure things, right? And the final piece was sharing again, because as I mentioned earlier also, dev and ops, they didn't understand each other's domain that well. Now, if you have to create a bridge between them, it's important that they are open with sharing their knowledge and their best practices, right? Because if people are thinking that, oh, I need to hold on to this information because then only I'll be important in the system, then it becomes a problem, right? It's an antithesis. And that's why sharing became one of the critical things for the companies, for the DevOps framework, right? And then you might be thinking, oh, that's great. It's good to hear. It's great thing, great thought. But then, how do I apply this framework, right? Is it like what I've been doing? Create scripts, pass them together, and so that something can be deployed from one stage to another stage. Does that mean that I am using great DevOps principle? Our company is doing great as a DevOps standards that we are following. Uh, I think uh, I believe that the answer is slightly different from this, right? Because DevOps, if you look at it, is a very complex field. It requires you to learn multiple things. You need to be good in infrastructure concepts, right? You need to be good in interpersonal skill sets because you need to talk to different stakeholders to bring them together to make it work, right? It requires great amount of analytical skills because the complexity of the systems are increasing day by day by day, right? So earlier we had private data centers, then we went to clouds, now we have Kubernetes, Dockers, right? VMs have been replaced. So the complexity of the systems is increasing day by day. So that analytical capability is again something which is very, very important, right? And then finally, the programming skills are also important because ultimately you might require to experiment with something which nobody has experimented before. So how do you do that? Only if you can build it. And building that should not be again a slapstick putting together of just scripts. It should be more like a product, not like a script which we do currently, right? And what I'm gonna do is I'm gonna in the succeeding slides, what I'm gonna do is I'm gonna do two things, right? So one is I'm gonna tell you about what are the important principles which you can use whenever you are thinking of building a particular capability, DevOps capability in the system, right? I'll also take certain examples of that as to how Defron did it, and finally I'll tell you like what are those important matrices which you should be always monitoring as DevOps folks, because those are the matrices which are actually telling you whether what you're doing is making things better for your users as well as for your company or it's not, right? So these are the certain set of things that I'll be doing in the succeeding slides, right? Right. So the first thing that you should think about is the right domain abstraction, right? What does this mean? It means that you should think who your user is, what kind of skill set the person brings in today, right? And if the person has to use the product or the tool that you have built or you have used to provide them certain capabilities, what kind of learning curve they would require, right? And even after that learning curve is done, how much continuously do they need to keep on learning, right? So those are the things which are important. Why? Because developers already have to understand things which are related to development, their own languages, Kafka, MongoDB, PostgreSQL, right? So other multiple different systems which they have to sort of interact with on day-to-day basis. Then there are new libraries which keep on coming in, new capabilities which keep on coming in, which they have to be abreast with on the application side, right? So if you're building for developers and you are telling them, oh, you need to know what infrastructure is, what how AWS operates, right? You are setting a wrong expectation for yourself. That's not what they are supposed to do. Similarly, if you are creating something which would be used more by the people who are adept on the infrastructure side, and you are expecting them to know the internal details of the application, then again you are doing wrong, right? I'm not saying that they should know nothing, but I'm saying that your system should not be forcing, right? So whenever you're building a feature, You need to think, okay, who is my user? What's his profile? What he or she knows today? What he or she would be comfortable knowing more? And those are the information parameters which would go into deciding what kind of abstraction, what kind of APIs, or what kind of UI you should be exposing to the user, right? So now, taking example, as I was saying, so taking examples of how Devtron does it. So one of the problems that we face is that as as I was talking about, there are multiple verticalized products, right? You want to do GitOps, there is one product. You want to do security scanning, there is another product. You want to do CI, there is a third product, right? So multiple products which are there. Now, how many products do you want your developers or your DevOps team to learn? As well as over time, you might say that, oh, I want to change this product, right? Because there is a better version which has come in, or there is a different product which has become much more popular. For example, now Kubernetes has become the flavor of the season, right? do does every time that happens, your developers, your DevOps, or your infrastructure team, do they need to sort of relearn everything from the scratch? They have to onboard onto a different system. If that is the case, then again you are doing things wrong, because they should be talking in their abstraction language, right? And things should happen below the hood for them. Whether you are adding something or you're removing something, it should not be, or changing something, it should not be their concerns per se, right? So that essentially means that your changes are not dependent on learning. That also gives you the freedom, because now you can replace things internally, right? Because they would not worry about it. On, if you are comfortable, you can just go ahead and start replacing the things internally. But if they are exposed to everything and you say, oh, Argo CD was great, now Flux has come in and I would like to adopt Flux CD, Flux 2.0, they would be like, wait a minute, we took a lot of time learning Argo CD, we don't want to now spend the rest of our life learning Flux, right? So this is something that you need to take care of, right? Similarly, when you are talking something, you should be talking in their language, right? So for example, developers inherently understand Git hashes commit, right? That's how they work with their code. They would push to it. There would be a certain commit. There would be commit messages. There would be a date, who did it, right? So there is a certain set of information through which they relate to the code that they have done. Now, if you are able to transfer this particular information about Git hashes and the related information throughout the whole value chain, right from build to, let's say, security scanning, testing, deployments, cost optimization, whatever that is, right? So the complete value chain, then it becomes much more easy and intuitive for them. They know what to do, where to fix it, when to go back to it, right? So all of those things become much more easier, rather than saying that, oh, I have a Docker image. Now, if you want to relate it to code, you have to go somewhere else, or maybe you have to do some jugglery to figure out which Git hash does it belong to, right? So those kind of things we should take care of while we are building stuff. Again, resource, CPU, memory requests. So the idea is the same, that I should be talking about things that I care about, right? I should not be talking about things that I don't care about. Two, I should be able to take calls based on the information which is provided to me, right? So if you look at it, it is telling you like, okay, what does this mean, right? And it's in context that you are getting that information. It becomes way too easier for your users to take a call as to what they should be doing, right? Again, the other thing in this example, again, if you look at it, we are talking about the right level of abstractions, right? So you build a plugin, you are exposing only those things to the users which they care about. There is enough documentation, description about the variables. You have a list of the variables. So essentially, what it is doing is, it is telling people that you don't have to rely on your memory. All right, you have information at your fingertips at the right place. This is how you should be thinking about your product. If your product is requiring certain information which needs to be provided by the developers, let's say, or the operations team, how easy or difficult it is for them to do it. Are they gonna be able to pull it out very easily, or are they gonna be have to go to like 4 or 5 different tools and spend 30 minutes to just fetch that information so that they can put it into your system, right? So that is how, that is another thing how you should be looking at, right? Again, from the domain abstraction perspective, for example, if I talk about Kubernetes, do you want people to learn kubectl command? Like if they have to do exec, how they should be doing it, if they have to do log, how they should be fetching it, or if they have to look at manifest, how they should be doing it, right? So do you want them to do that? Or you want them to just say that, oh, I want to look at the configuration, and they should be able to look at the configuration without remembering the commands, without remembering like which kube config do I need to switch to which object do I need to fetch, right? So all of those informations again should be kind of abstracted out, right? Second thing, whenever you are building a feature, you should be thinking about ownership and delegation, right? Who is gonna own this particular capability that I'm building, right? And whether there would be certain delegation requirement, right? Because I may be an owner of a particular capability, but I may be fine delegating certain portions of it to the relevant person within my team, right? So is your product or is whatever system that you're building capable of doing it? Can you identify the right owners for that system? And that's how you should go about it. I'm building this. Who is gonna be the owner of the system, right? What kind of capabilities he or she would want to do themselves, and what kind of things they may want to delegate to their other team members, because those people are more suited to do it. Just to give an example, a lead might be fine saying that, oh, I'm going to own the application because I know about the application. But at the same point of time, if an issue happens, I would have rather my team member who deployed that particular feature debug it rather than me going and debugging it, right? So I may want those certain set of things to be delegated to that particular user, so that that person should be able to do it by themselves, right? So that's the ownership and delegation. You can typically think of it as two metrics, right? So two orthogonal points. So one is saying that what is the granularity of the access that I can provide, right? Uh, 1, 2, 3, 4, it's just one that everybody is going to be a super admin, or it's going to be, let's say, something with the view only access also. And second thing that you have to think of is the feature angle, right? So these different access controls should be mapped to the right feature set, right? Because if you haven't mapped them to the right feature set, then people will not be able to delegate it properly, right? So just to give an example, let's say if I say that a person who has a view access, if I map a person with a view access also to an exec in a terminal, it becomes a problem. Even if the capability is there and there is enough fine-grained control systems, as a lead, I may still not be able to delegate it to the person because that might become a problem, right? So now again, talking about how in Deptron we do it. For example, we have something called an application catalog, right? So application catalog allows you to go and search for any of the microservice or application that you care about. Maybe you own it, maybe your application talks to it. You don't own it, right? So, but you can talk to them and you can figure out as to who is the right person that you need to talk to, right? So if, and especially it becomes true, more important in today's complex world where people are saying that so many microservices are working together, you may not know, even if you're talking to a particular application, who owns that application, right? So this system makes it, makes the collaboration much more easier, right? Between the different development team as well as the development and the ops team, right? Similarly, if you look at it, this is about the fine-grained access control, right? So they are, as I was talking about the different labels, it's like view only, build, deploy, admin, manager. So what are the different access label controls you have? You can even customize the access control or not, because between different applications, you may want to have a different kind of capabilities or different kind of access. An application which has very sensitive data, you may not be okay with giving a lot of control, right? And then again, some of the other example where we are saying that sensitive data, even if it's a view only access, let's say you should not be able to look at secrets because secrets is a sensitive data, but you may still want to look at the keys of the secrets, because so that you know that you are using the right keys and you have mounted them properly, and that is not a reason for failure of the system, right? And then we talk about visibility. Visibility, again, if you look at it, what you need to, whenever you have a feature, what you have to think of is, because there are multiple parties which might be involved in this particular feature, right? Different team members which are coming together. What are the important data parameters that needs to be captured and to be sort of provided to them so that they can have an end-to-end debugging and visibility capabilities, right? Because you are also delegating things. So as a lead, I have delegated to my team. Now somebody in my team made a change. If I don't have visibility to that, like who made the change, if an issue happens, it becomes very difficult for me to figure out like who did it. I'll have to probably ask each and everyone saying, did you make change? Did you make change? Did you make change? Rather than saying that, oh, you two guys made these two different changes. We have an issue. Come in and let's try to solve it. Right. So the more parties which are getting involved, visibility becomes critical. So again, when you are looking at a feature, you should think that Okay, what are the different parties which could get involved? What is the kind of visibility that they might have within their own system, ecosystem, and what kind of information beyond their ecosystem they may want to have, which is of course not sensitive in nature, but would sort of make their life easier, right? So this is another question that you should be asking, like what all information I should be logging, and who all should be able to sort of, and what should be the sensitivity level of that information, right? Again, in this screen, if you look at it, we capture deployments, we capture builds, we capture what were the configurations which were used for that particular deployment or for that particular build, so that if you have to, and who made those changes, so that you can just go back and say that, okay, this change was made by this person and we need to sort of revert it, or we need to talk to that person to figure out. Same thing is for the audit logs. Uh, somebody might have revoked access to a certain key. Who revoked that access? So that you know what was the reason behind it, right? So those kind of things. Uh, Again, in visibility, the other thing which comes in is the change management, which I was talking about, right? So you made certain changes and you deployed it, or you made certain changes and you built it. Can you see the difference? What has happened since the previous changes, right? And what kind of changes have actually happened? Can you figure it out? So those kind of things also you need to sort of take care of, right? And then finally, if you have to debug the things and there are multiple stakeholders, is there a single place where they can come, or a screen where they can come and say, oh, we are looking at the same information and therefore we can figure out the root cause faster, and all of us would be agreeable to the final solution or where the issue is, right? Because if different people are looking at different information, they may come to different conclusions which may not be compatible with each other, and then it becomes difficult to sort of quickly debug the things, because most of the time is spent in trying to explain like why what I think is right? So so that's the visibility aspect that we were talking about. Then the other thing is repeatable, reproducible, and verifiable, right? So anything that you're doing should be repeatable, it should be reproducible, and it should be verifiable, right? So what I mean by that is repeatable essentially means that it's not about you doing it again and again and again. It's about saying, oh, if I am not available, can any of my team member in my absence can do it without involving me? That's the repeatable nature, right? If they can do exactly the same things which I was doing without even me being present over here, then the system is a repeatable system. You can repeat what you do, what you did, right? Similarly, for a reproducible system, even if let's say me or somebody else repeated the same steps, are we getting the same output? Because if we are not getting the same output, then the problem is, even if the other person can do the same thing in my absence, the output will be very, very different, and the person may still have to like debug the things, right? And one of the very famous product which did it very well was Terraform, right? So before that, the problem was you were always talking more in terms of, oh, I need two more instances, oh, I need four more instances, I need to reduce the instance now. Now, because of that, what was happening is you need to keep in your mind as to what's the final calculation which has happened, right? So maybe there was race conditions, some were coming up, some were removed. So what was the final state which the system was left with? But then Terraform came in and Terraform said, oh, you just give me the final state. It's my headache to ensure that that state is maintained, right? And that made the systems reproducible. Why? Because if you have said four instances, you will get four instances. Otherwise, the problem was I said four instances, then I said plus two instances, then I said minus one instances. Now, what should I tell the new system? I don't know, right? And finally, it has to be verifiable, right? Because uh, it, unless and until I can verify that things are repeatable, things are reproducible, it's all in my head, right? So that is why I should be able to verify it over time and time again. That means I should also be running these things from time to time to ensure that the repeatability and the reproducibility of the system has not been compromised over time, right? Now, again, taking example of the system that we have, right? So if you look at DevTron, again, we expect user to provide us the final state, right? And it's our headache. How do we reconcile it? For example, just to give an example, you might be using HPA. Now, when you initially said the minimum replica counts were 4 and the maximum were 8, and you asked it to have 4 replicas, and over time it is scaled it to 6 replicas. Now, when you are doing a deployment, you don't have to worry about how many replicas are running currently. The system takes care of it and says that okay, because 6 replicas are running currently, you should be doing a deployment with the 6 replicas so that none of the replicas are removed or added, right? So that makes the system uh, reproducible and repeatable, right? So you don't have to worry about these things, right? Similarly, it's very easy for you to roll back to a particular version, right? Because if my things are not working, I should be able to just say that, oh, this is the last working version. I will just go and click and say that just deploy it, and it should work, right? So that these are again examples of repeatable and reproducible system, right? Now about the verifiability, what would happen is, again, you might have heard that, oh, you should be testing on completely identical systems, but that never happens. You can't do it. Your production load may be too high. Your production data may be too different, right? But one of the things which are important for you is to verify the diff which has happened between the environments, because that will give you idea of the scope of the impact, right? And you would be able to take calls with a certain level of confidence as to what would happen once you would sort of do this action, let's say on a QA environment or a staging environment and on a production environment, right? So diff across environments, what has changed, how they have drifted, and then again you might be reconciling them over time to time, because there are certain drifts which may not be desired drifts and which you can actually control, right? Uh, the other thing that you should be looking at is to say that you would want your feedback cycles to be tighter, right? Because again, and when I say feedback cycle tighter, I'm not just talking about the task that you did, right? Of course, the feedback of the task should be as soon as possible. But what I'm talking about also is to say that if you want to build a feature, you should first go out and talk to your users. If an operations team is going to use your feature or a development team is going to use your feature, the first thing you should be going is talking to them and understanding their main pain areas, right? You should even be sharing your probable solution with them. Maybe they might be able to come out with help you arrive at a better solution, right? So feedback cycle is not just about saying, oh, once I've built my product or built my capability, then I should be continuously capturing the data related to that capability. You should be doing that, but your feedback cycle, it's like a shift left, right? So the sooner you are able to take feedback from your prospective users, the better it is for you, right? So think of it as a product and not again as a script where you are saying, oh, I'll give them something and what I believe is the best. If they would have certain issues with the capabilities, then we can think about it, right? That's not how it should be. And again, taking example of Devtron, we capture deployment frequencies, right? So what is the deployment frequency? How often you are deploying? What is the change failure rate? How many times you are failing, right? So these kind of things, these kind of metrics we capture, and I'll talk about it later also. But these are the kind of metrics that might help people figure out what's happening with the process. Then they might also have application metrics. So application metrics is essentially saying that, oh, I made deployments over time. What has changed? Has my latency increased? Has my error status code increased? Has my memory usage or CPU usage increased? Right. So this again provides teams capabilities to figure out how they are going, where they are going, and then they can course correct. Right. Finally, it's about the shift left. Right. So whenever you're building again a feature, think the feedback that you're getting at that particular step, could you have gotten that feedback a step earlier? If you could, you should definitely try to get feedback at that particular step, right? That is the whole idea of shift left also, right? So if something I can discover in production environment, I would rather have it discovered in staging environment or pre-production environment, right? If there is something that I can discover during a deployment, I would prefer to discover it during a CI step, right, or a build step. So what I'm trying to say is, whenever you are building something and you are looking at saying, okay, this is the feedback that I expect, you should say that, can I take it a step earlier and get feedback even earlier, and that would allow us to be more tighter and more quicker in the sense, right? And finally, adaptability is the last point, which I believe you should be thinking about. Adaptability is thinking of like it's as an evolutionary system, right? So there is a great book called Evolutionary Architecture. It essentially says that you should architect your things in such a way that you can make it better over time, rather than trying to build a system which takes care of everything, right? As a DevOps, also that's the problem that we have to continuously sort of deal with. So many new things keep on coming up. It's very difficult to keep up with them, right? And uh, how and what should we be doing? Uh, should we be building things just for what we are focused on currently, or should we be building things for a future that we haven't seen? And most of the time, as a DevOps engineers, we take a call saying that okay, but we know, let's do that and forget future, right? But this system is, but what you should be thinking about is saying that, oh, if I have to modify the system, do I have such clean interfaces with clean documentations that I can do that easily? That's the question that you should be asking yourself, right? And again, there are certain examples that I have put in which says that uh, it is your system easy to integrate onto new systems, right? Argo CD has come and you want to use Flux, how easy difficult it is. Argo CD's new version has come and which is more capabilities, how easy it is to upgrade it, right? Or you were not doing initially when you started off, you were not doing testing. Now you want to introduce a step of testing, right? How easy or difficult it is, right? Uh, you were using security scanning. There is a critical vulnerability which has been discovered with no fix. Can you put an exception, right? So the idea is that can your system evolve over time? That kind of thing, thought process is baked into the product or not. You should be thinking along those lines, right? Making sure that the API or the interface allows you to evolve it. And then finally is the measure outcomes. So it's a DORA principle. Because you have been doing everything, now you need to figure out whether your efforts are giving you the kind of dividends you want or not. So there are four specific metrics that you need to be capturing. One is the deployment metric, deployment frequency, how often you are deploying. If your DevOps system is maturing over time, this frequency should keep on going higher, right? Change failure rate essentially says that how how many of your deployments actually fail, right? So again, it should be as low as possible, but you should not strive it to be zero exactly. You should try to contain the impact of the change failure rather than saying, oh, I would never have a failure, because then you would be sort of reducing the frequency of your deployment, right? If you want to attain that. And then you have a mean lead time, which essentially says that the oldest commit, how much time it took for a commit for us to take a commit to production, right? So that's the lead time, because that's when developers started coding it, and then finally when it got deployed, right? And then it's a mean time to recovery, which essentially says that if an error, if a failure happened, how soon I was able to recover it, right? So these four are the metrics which you should aim to continuously improve on. Any feature that you are building, any capability that you are building, you should be asking yourself, is it gonna make any positive impact on any of these matrices? And then you should also go back and measure those impacts, right? And that would be it about what I wanted to talk about. As I was giving you some of the examples of how we have done things on Devtron. So in Devtron, so I would really love if you would like to check out Devtron. It's a Kubernetes focused product. The idea is to sort of make you guys make you guys free of the daily course and focus on things which actually matter for DevOps and are able to sort of create that kind of value addition for the company, right? So would really be thankful if you could go, love, like it, like this, and try it out and give us your feedback as to what do you like, what did you not like, how we can make it better. Thank you, Karthik. I think we can open for the questions.
Hey Prashant, am I audible?
Yes, you are now.
Yeah. So there aren't like any questions in the live chat,
Perfect.
but I would like to thank you for such an informative session, Prashant, for explaining us
Thank
how
you.
the DevOps principle and the what is the working mechanism. And
Thank you for hosting us.
yes, if you guys have any questions for Prashant, you can reach out to him on social media. The links can be found in the description of this YouTube video, and you can also start the GitHub repo as Prashant was mentioning. Thank you, Prashant.
Thank you. Thanks, everyone. Bye-bye.
Bye. Okay, then let's move on to our second session. But before that, just a gentle reminder that we also have a quiz at 7 p.m. and the winners of this quiz get vouchers worth 200 rupees. You can register for the quiz. The link is in the description, and same has been pasted here in this live chat. And I'm pasting again. So do register. The registration is free. All right. So let's move on to the second session for today's meetup. Our second speaker for this today's session is Ashish Tiwari, who is a senior developer advocate at Elastic. Hey, Ashish.
Hey Karthik, hi. Am I audible?
Yeah, you are audible. Yes. So, Ashish, could
Perfect.
you please give us a brief introduction about yourself, what you do, and what is the today's topic
Yep.
about?
Today we are going to have a look on APM, Elastic APM application performance monitoring, and how you can integrate with your code and you can just monitor your whole code. In fact, you can trace each and every transaction within your code. Yes, this is Ashish, and I am a senior developer advocate working in Elastic. So I have started my journey as a software engineer, having the 7+ experience in the software and email industry. I have been a startup guy as well, where I have over multiple hats. I have worked with support, technical architect, marketer, etc. So now I'm working as a developer advocate, so handling a community events. I do meetups, conferences, BBLs, etc. So this is how it's a short introduction for me. My DMs are open. You guys can reach me anytime. Is it good time to start with my presentation, Karthik?
Yes. So,
Yeah, should I start?
yes, Ashish.
Hello.
Yes, Ashish, you can start. Your
Yeah.
screen actually it went away.
Just a minute. Cool. Is it okay?
Let me check. Yes. Yeah, you can take
Perfect.
over.
Yeah, guys, let's quickly move to our agenda. We will quickly see why Elastic, okay, and then we will have a quick overview on Elastic stacks. And after that, we will quickly jump on Elastic APM, why to use and how to use. And if we time permits, we have a quick demo session as well. Yeah, let's start. So we are living in, it's today all world is getting digitized, and we generating data in every seconds. On every touch on our cell phone, it's generating the data you are tracking. With a survey, there is a survey like there will be 480 exabyte data is going to produce from 2025, and it's on a daily basis. It's a very challenging thing. Like if you want to make a search from such a huge database, it's going to be a huge problem. And if it is a very specific or relevant search, so let's talk about why search. So search you need for, search is everywhere. Search is if you are want to find the RCA, you want to pull out some data or analytics, anything, there is a search. Okay, even if you are ordering some delicious dish from any food app, maybe anything, so you need to have a search. And if you are booking any movies and like something, of course there is a search is only the solution. So here where the Elastic comes in the picture. Elastic gives the solution, where you can achieve such a different kind of search use cases by using Elastic Stacks. Elastic Stacks already powering lots of brands and enterprises with the help, and they are solving their search use case. So one of the use cases of Uber, if you are typing, if you are searching for a, for a cab and you get the cab mapping, it's powered by Elasticsearch. So Elasticsearch having a wonderful location field type where you can just give latitude, longitude, or just country name or something. You are able to plot your everything on a map. So yeah, Uber is one of the example. The another example is a Tinder. It's a pretty famous app in a youth. Yes, so it's give the relevant search. So it is also powered by the Elasticsearch. So I'll go just the previous slides. So any app where you are see where you see like the search bar like this. So there is a very heavy chances it is powered by the Elasticsearch. Okay, and people are solving their search use cases. It gives the search as you type, and lots of combination of search. So here are the some of the we have happy clients who are using Elastic Stacks, and for the different use cases, there is Elastic Security, Observability, and Elastic for a search use case, logging analytics. They parsing their logs and searching among them. Yep. So we have a very good custom user story blog on our website. You can just go through it anytime. So yeah, how is it possible? So this is possible because of this Elastic Stacks. Elastic Stacks, who don't know the Elastics, so it's a consist of three major fields. Let's say first is Elasticsearch, second is Kibana, and third part is a collection of the integration, various integration. So I'll give you the quick overview of what is Elasticsearch. Elasticsearch is a distributed search engine and a data store. So it is a NoSQL. It store the data in a JSON format. And if you want to make a query, there is a REST APIs for the making a query, for the CRUD operation, everything. It's give the high availability, high performance. It's a horizontal scalable, so you don't need to take care about downtime and for a scalable thing. So there is a Kibana. Kibana is works on the top of the Elasticsearch. So whatever be the data in the Elasticsearch store, you can visualize, you can create a dashboard, you can create a charts, metric charts, whatever you want. There is a n number of the options is available in a Kibana. Kibana also come with the pre-configured dashboard as well. So let's suppose you are running a MySQL services and you want to monitor. So what you can do, you can just get a metric bit downloaded on your host system. Just just configure it and give the Elasticsearch output. Give the Elasticsearch endpoint in the output, and it will start collecting the data for a MySQL health monitoring. And in the Kibana, you don't need to create anything. The dashboard will automatically get loaded into the Kibana, and you can just start exploring your MySQL. So this is one of the example. There is already there is already pre-configured dashboard available for Mongo, let's say Redis, Kafka, MySQL, and you can just plug in play and you can start your monitoring for particular services. So this is something a Kibana is. You can more explore on a net. We have a wonderful documentation for it. And Beats it's a come in integration part. Okay, so Beats is something which is a data collector. So it's collected data, different types of data, like depends what kind of beat you are using. So there is a multiple beats are available. If you want to collect a metric beat, like metrics of system metrics, you can use a metric beat. If you want to collect a network data, you can just install the packet beat and you can just get start. If you want to read from from log file, and you want to just get into the Elasticsearch, you can just use the file bit. So in the file bit, just give the log path and just point the Elasticsearch. The file bit automatically start reading in the real time, and it will push to the Elasticsearch. So it's a simple plug and play game. You guys can explore, you can play with around this stuff, and you can use it. So Logstash is also part of integration. Logstash is something, it is a ETL part. It's extract transform like this. You can give input and do the data transformation, and you can specify the output. So for example, I can give the input as a read from file or read from MySQL, and the data it will read the data. You can do the transformation, and based on rules you have specified in the Logstash, and you can then it will forward to the output. Simply in output you can define Elasticsearch, MySQL, whatever you want. There is options, so you can just go and explore it. There is already 250 plus plugins are available, which is developed by community. You so if you have any use case where you want to perform some ETL, don't don't straight away to go write a solution. Just have a look on a log stage whether it's pre-built, some solution is already available. So yeah. So before I go move forward, let's quickly create one instance on a cloud. You can simply go on cloud.elastic.co, and I'm just simply creating a deployment here. I can give the deployment some on meter. So you can also create in the same way. We have a 14-day cloud trial also. You can just explore the Elastic Cloud for the 14 days. It's free. So here I can choose the cloud provider like GCP, AWS, Azure. I can go with the GCP. Take take a choose your data center where you want. I can choose the Mumbai and start the create a deployment. So it will automatically create a deployment. So let it be. It's going to take a 2-3 minutes. Till that, I'm going back to the yep to the slides. So as a developer or DevOps, whenever this happen, what uh, it is like this internal server error. Okay, it's something 5xx. It's a server error, or it's like a loading. It's an annoying loader. Okay, for anyone, for me, for developer, for DevOps, or maybe for your users. Okay, it's so what happened at that time? You have to become detective of your system, right? You start debugging things. Okay, in most of the cases clients become to know first, and they come to support and they raise the tickets, and it's loading, it's taking time. So as a developer or DevOps, you're starting debugging things. You start taking a logs, you start checking whether some of the service is still up or not, or it went down. You check the resources, okay, to check the memory, check disk, whether it's get full or not, or you just check, go through the error. It's a global check. Okay, so I know all of you are familiar with this command. So developer like me, they does like this. So I used to print every variable, oh, where it's break. So yeah, these kind of the some of the example, and we end up with the opening multiple screen on our terminal, right? We having such a situations in. So if this is a single machine, it's okay. But what if it's your architecture is distributed? Okay, it's again hard to repeat same thing on this all servers, right? So here where APM comes in a picture, the Elastic APM. APM is a general term, application performance monitoring. But here what it is, Elastic APM is used to collect all kind of traces, transaction from your distributed system, and it used to push into Elasticsearch. And once your data gets into the Elasticsearch, you can visualize from Kibana. So you can visualize each and single transaction, each and everything, whether it's generating any error, whether it's get down like this. So hopefully we can achieve this on a demo. I think I'm going to cover in a demo this how it works. Let's quickly check how Elastic APM works. So this is the raw architecture. So every machine, let's suppose you have a distributed system of 10 servers. In a 10 server, there is a one, like what we can say, there is a 5 containers is running. So one is the container PHP, Java, Go, Ruby, or maybe a Python. So every language you have to configure one APM agent. We have agents available for multiple languages. Most of the famous languages we having. Definitely, I'm going to tell you the list. But what happened? It's suppose I have my application written in Go. So I have a Go. I'm going to integrate my Go APM agent with my code base. uh, I am going to trace each and everything. I'm going to tell you how it will be. It will going to start collect your data for each and every transaction, like for database query, for any if you are making any third party query like this, and it start sending those data to the APM server. Okay. Now here is the APM server is the single server whose work is to collect the data only, okay, from the different agents. So suppose I have a one container with a Go, I have a one service with the PHP, Java, like this. They are going to send all data to the APM server. uh, APM server, it takes the data, it does some operation, and it start pushing to the Elasticsearch. So yeah, your data once it gets into the Elasticsearch, there is a dashboard is ready into the Kibana where you can just go and you can just start exploring how much time it taking, if something is slow, which segment is taking time. So this is how you can trace your whole code base, your whole workflow with the Elastic APM. So what about the agents? What are the agents? Let's say it's a language specific agent. We having a PHP, Java, Go, and we have a framework specific as well. For Java, there is a Spring. For Node, there is a Express, like this. And you can attach to your application, right? And it's a lightweight agent, so yeah, there will be no overhead, and they are going to track each and every transaction. They are going to trace your whole code base. So what kind of data agents collect? So there is like four types of data: span, transaction, error, metric. Span is nothing but the small chunks. Let's say what is about the SQL queries, about the Mongo queries, or any if you are making call to the any third party HTTP request. Yeah, that is your span. Transaction is the collection of the spans. Okay, so there might be error, it can be exception, it can be DB error. So if you are using if you are using the SQL specific agent, then it will be going to again automatically get the it will going to track all database related error and going to push to the Elasticsearch. Metrics, yes, it's also collect the metrics. It's like a system metric and calculate system metrics like your memory CPUs, and calculated metric is like it's do the some calculation behind it. Okay, so for by calculating average frequencies like this. So how do agent work? Agent is a wrap operation with standard library. Okay, there is a one library like let's say Express. We have an extended library for that. You just integrate it. It measures the time for all those operations. Like if you are making query, how much time it takes. If you are making third party call, how much time it takes. And like this, it's continuously send the data to the APM server, and APM server forward those data to the Elasticsearch. So this is how agent works. Yeah, this is one of the examples. So let's suppose you have one transaction. Let's suppose products. It's just transaction name. In products, it's what is happening. It's going to show you like this. In products, you are going to call HTTP to a get call. In that get call as well, there is a parsing document. There is a open beans calling JS, and here as well, it's going to drill down at each and everything, each and every single segment you can try. Okay, so yep, Elastic APM, we have agents available for these languages: Go, iOS, Java, .NET, PHP, Python, Ruby. And if something exception you are expecting, yes, you can always raise a ticket to our engineering team, and yeah, they can definitely take in a product map. So right now we have for a mobile purpose, we have a iOS agent. Android is still in under development, but we are going to release very soon. Okay. So instrumentation is there. So what is the instrumentation? Instrumentation is nothing but adding a few more code in your existing code base to monitor it. Okay. So this is one of the example for a Golang. Like there is we have given APM SQL. It's an extended library of database SQL. So you can just directly use this library and make a connection as everything. And that particular library is automatically going to monitor each and single query. You don't need to explicitly define some transactions and span. So I'm going to show you how. There is custom instrumentation also possible. Suppose you don't want to use these kind of framework libraries like APM SQL or Express or like this, and you have a something custom requirement which you want to calculate, you can do it. Of course, you just start a transaction like this, start a spam, close the transaction. So it will collect the particular chunk, and it will monitor, it will collect the data, and it will send to the Elasticsearch. So it is simple. So we have a demo time. In demo, we having a four types of services. One is a router, which is going to run on 8,000 port, and it's going to whenever we're going to hit slash router slash users, it's going to redirect particular request to respective service. So if slash users request is coming, it will going to 8001 port slash users, and if slash projects is coming, it will forward to the 8002 port, like this. So, and these kind of the service, these all these services are going to communicate with MySQL as well. They are going to push data in MySQL and read from MySQL. So we will see how it's going to work. So perfect. I'm going to my terminal right now. Okay, this is my MySQL is running. This is my Redis running. This is some of the sample curl call, and we can start from here. Perfect. I'm just doing quickly ls. Okay, so I am having router.go, user.go, and projects.go and task.go. Okay, uh, so as I explain here, router, user, projects, task, correct. So I'm going to run each service in different tabs. So let's start with the router. I'm sorry, let me first configure the APM. Let's go. We have made one deployment here. Perfect. I think it's the deployment is ready. First, let's see here. So I'm going to download this credential. Once your deployment has been created, let's don't forget to download it. Have it downloaded. I'm just doing continue. So it will redirect you on a Kibana dashboard. Okay, I'm going to explore on my own. So this is something Kibana dashboard, and in Kibana you can explore these kind of the all option. There is the enterprise search, observability, security, analytics. Uh, yeah, enterprise search. It's also come with the app search, workplace search, observability. There is a lots of option available: metrics, logs, cases, alerts. Security, it's provide the endpoint security, network, users, etc. So today we are going to focus on observability, and to be more specific with the APM. So I'm directly going with the APM here. Cool. There is a no data, right? So I'm simply going to have add data. Okay, and just check whether APM server status. Yeah, it's running. Okay, it's running. Cool. So in a cloud option, it's the APM server is automatically come with the pre-configuration. But if you are running on premises, you have to download Elasticsearch, Kibana, APM server, and the respective agent to, and then you can just connect, configure all with the Elasticsearch, and then you can start, you can establish your flow. So right now we are using a cloud, so simply go on. So I'm going to have a go session, right? I'm going to give a demo on a golang, small golang apps. So you can just get your library like this, go get. So this is, I have just taken an example of go. It is a possible with all of these languages. There is a PHP, .NET, Java. You can just click, and it will show you the path how you can configure the APM, right? So I'm continuing with the Golang. So here's the credential. I'm just copying, and this is the environment variable you have to set. So I'm just going to set in my Z profile. I already pre-configured. Okay. So here I'm just pasting. I'm just doing source. Let's make sure. Oh my. Cool. It's, yeah, it's there. So now your Go agent will automatically read from this environment variable, and it will start pushing the data on this respective endpoint. Okay. So let's do it. So now let's get back to here again. We have a demo routers users. So let's start a router service first. I'm just giving you the little overview. So here I have created a endpoint here, a router policy. So if there is a user, it will be redirect to user proxy function, and users proxy will be do nothing but it will do nothing but the port forwarding with the whatever request is coming. It is a simple. So yeah, let's run this. It is running. Now I'm going to run all the services in individual tab. So we have a router, we have a user. Let's run users. That we having a projects, we having a task. So here port 8002, 8003, and 8001. All three services running on these respective ports. And there is a router which is working on, which is running on a 8000. So let's now make some calls. Okay. I have a call ready. It is nothing. It is a simple name, department, role. This field we are going to post. And so it's giving the response. The data has been inserted. Now, the what it does, it has called this localhost 8000 users, which is a routers is running. In the router, I have already configured the APM libraries. So if you can see here, I've already used APM HTTP. I have also used the Go Redis of APM Go Redis library of Elastic, and I have also used the Redis as well. So I'll come on this. Let's. So one transaction has been done. Let's monitor on the Elastic APM. Okay, and I can simply launch APM. Okay, so this showing router user projects. So transaction time request, these two services showing there is some transaction happen. Okay, now I'm going on a router first. Yep. So this transaction has been occurred slash users post. The dependencies is Redis because it's going to take a Redis call. Why? Because we have given the API key 1234567. It's an example, and it's going to cross check in a Redis. We have set in a the same key in a Redis for authentication purpose. Okay, cool. Now let's have a look on transaction. Just click over here, and yep. So if you can see this is my whole transaction. Transaction was post slash users. In this, it forwarded the request, okay, with the post SRV users. And after SRV users, it's connected to the MySQL. And in the MySQL, this query has fired insert into users table. So you can see how it's easy. And each and every span is coming with the time, how much time they have taken. So my whole transaction have taken 10 ms. In 10 ms, it's a 2.3 ms taken by this API, 3.2 ms taken by this API, and 1.2 ms by SQL queries like this. So you can just go the metrics. Yep. So it's also calculating your CPU and memory. It is the same. This data is same calculated by the Go APM agent. Now here is the interesting part: the service map. So if you see how your the transaction is going to track, the same way your service map, service structure is going to build here. So there was a router. A router was connected with the Redis as well, because it's fire one query to check for authentication purpose, and it called to users as well. And then users API call fire one query to the MySQL. So let's quickly fire few more queries. Okay. Now I'm going to fire a task. Let me do. And I'm also going to fire projects. So it's going to insert one record in a MySQL table, but I just want to give you the overview how it's going to work. So again, let's move to services. I think data is not coming till now because it's showing, yeah, now projects data is there. Let's go to projects data. In projects data also, you can just drill down which exact transaction happened and what it takes. So in project service specific, there is a one query has fired, insert into projects table. So if I want bird eye view, let's go to the router because that is our starting point. Let's go to projects, and then here is the bird eye view. You will get the total overview how it's going to work. So this is how you can achieve, you can just insert, you can just I think integrate the different kind of agent with your system, and you can explore more things, like what, how your code is behaving, where it taking time like this. So yep, we having this demo. And also there is a custom instrumentation possible. So in a custom instrumentation, let's say this is example of Go, but it is also possible in a different language. um, Here is the transaction started. So I have given the transaction name, message, in topic, consumer, like this. And I have also started the span. Here I have given the name, select from food. This is just example. You can give anything. Okay. And span dot end. So I can just add some sleep time. And then I'm going to run this script. So I'm going to have second. There is a 2 second time sleep I'm adding. So let me run this. Let's see if it works. Perfect. Go run custom instrumentation. So I'm going to again services here. Yep, it's here, custom instrumentation. But I'm not seeing a data. Let me check. Maybe it will take a few time. Oh, okay. There could be delay. Cool. I need to figure out why why this happened. But I think just let me check quickly. Should come. Let wait. Let's wait. There's an interval time. Uh, yep. Now it's transaction here. Data is here right now. Custom instrumentation. Let's go here. This is the same name, the transaction name which I specified, message in a topic, consumer. Let's click here and let's take a look. So here message and a topic, consumer, it took 2.2 seconds. Okay, where the 2 second was this query which I have added a sleep time, right? So this is how you can trace down your custom code as well. You don't need to use like a framework specific APM agents or APM module. You can just start span like this. Just add your code between this and just end your span. And after that, at the end, you can just end with your transaction. So yeah, this is how you can do a custom instrumentation as well. Now let's go to the service map. Yep. So here is the service map. Router has communicated with the project service and the user service because we have added one entry to each. Project service also have pushed some data to the Redis, and also it has pushed the same data into MySQL. So yes, and user is only interacting with the MySQL. So if you have different services running, it's going to come here, and you will have a bird eye view of your system architecture. So this is how you can do the cool things with the Elastic APM. So yeah, that was the demo. Let's get back to slides again. Perfect. So I hope this demo you will get the idea you can achieve with different languages as well. This was a distributed tracing call, okay, and how it works. So distributed because it's depend server to server. There will be different kind of code base. There will be different kind of language. So it works on this. There is a trace parent ID, which is common for each transaction, and your each transaction can be possible throughout your distributed system. So if your transaction is starting from server A1, it the same transaction will be traced till server 10 as well. In same transaction there will be multiple types of span error will be there, and you can just visualize those traces in bird eye view as I shown in demo. So, yep. So here is what APM can do. Infrastructure monitoring, of course. We have a metric beat for that. If you are monitoring infrastructure, if you want to monitor infrastructure, what is the RAM, disk size, like this. Uh, but APM also collecting those only for RAM and CPU. But if you want to collect disk or IO like this, go for a metric bit. Log analytics file bit is there, though it don't do, and security attacks it doesn't prevent. So yeah, APM has a use case. You can just trace your whole code base kind of thing. Uh, there's a more option to explore. You can explore by yourself, like a real user monitoring. It is a JavaScript based framework. Like you can integrate with the React and like other frameworks, so that you will get the complete user journey from front end to back end. And you can also explore the transaction sampling. So in the future, I can cover like these 2 points. So, if you have any query regarding this, you can always reach out to me, or you can just reach out these communities, discuss.elastic.co. We have a Slack community, and also we have a contributor program. So, yes, if you are interested to contribute in terms of Stack Overflow answers, code commit, or anything, just reach out to this program. We also running different user group chapters in a different cities. So this is one of the example of Bangalore. You can, if you are from Bangalore, please join it. We have a different user group as well for Mumbai, Delhi. You can just search on a meetup. You will get it, and just keep subscribed. We are doing meetups, and you will get notification. So yeah, that is it from my side. Thank you, folks. It's time for questions.
Oh, sorry, I was on mute. Hey, Ashish.
Hi.
Yeah. So first of all, it was a wonderful session, Ashish, and we have one question in the
Thanks.
chat.
Sure.
The question is, what's ETL? I've displayed on the screen.
Okay, so I think it was talking about a log stash. Let me go to the quickly. Yep. So ETL is extract, transform logs. Okay, collect and parse. So what you can do, you can give the input, anything as an input. Let's say read form file, MySQL kind of thing, and do the transformation. Whatever you want to do, data manipulation, you want to do data modification, like these kind of the operation, and then you give to the output. Output can be anything. Let's say I want to read from MySQL data and push to the Elasticsearch. Okay, but before pushing, I want to do some operation. So I can use a logstash. I can just point out my MySQL in the input and table name. It will give me the data in the real time basis. It will do the data modification, and it will push that particular data to the Elasticsearch. So it is simple. It's you can just get, modify, and just push. It's ETL. Hope this will help. Or
Yes, hope this helps, Sandeepan. Yeah, I hope your question is answered. Yes, though that is all, Ashish. Oh wait, there is
Awesome.
a question. Can
Okay.
Elasticsearch be used to search location and within the radius? If so, is there a pointer to example?
It won't be like this is not a radius specific, but yeah, it's used to store a latitude longitude. You can do the geolocation like this. It also search on a country's name or areas. You can just explore the geolocation Elasticsearch. Just let me check if I can quickly find, or yeah, this is a wonderful blog. You can just explore it. I will give it to you in chat. Finish share. Where to share, Karthik?
Just
In the
paste in
comments.
the comment section.
Okay, okay,
Yes.
perfect, perfect. I think it's not allowing me. Okay, cool. I'll
So could you please paste in this private chat? I'll
yeah, yeah,
post
yeah,
it.
please.
Yeah.
Great. If you have any doubts, you can just reach me anytime. I'll happy to help you. And we have a community as well. You can just ask your question definitely. But it was a wonderful. This is a wonderful use case. People are using Elasticsearch for this geolocation specific.
I think yes, the comment has been pasted.
Perfect.
All right, thanks Ashish for such a informative session. And as Ashish mentioned, if you guys want to reach out to Ashish, you can find his
Sure.
social links and his website in the description of this YouTube video. Thanks, Ashish.
Perfect. Thanks, guys. It was a privilege. Bye. Take care.
Bye. All right, guys. Hope you all acquired new knowledge about DevOps today. And as I had mentioned earlier, we have a live quiz shortly at 7 p.m. So do sign up. Top five people who top the leaderboard get gift vouchers worth 200 rupees. And I'm pasting the link once again in this live chat. Registration is free. You can register. All right. So we will wait for some time for the participants to join. Since this is a live quiz, also before the quiz starts, let me tell you some do's and don'ts of the quiz. So we recommend you to not be on VPN at it, as it would affect your bandwidth and may cause some lags. We recommend you to use either Google Chrome or Safari. And just in case if you get dropped out while playing the quiz, please join as soon as possible. And let's say if you get dropped out and you rejoin, You will be allowed to play from the next question onwards. And we also request you to not refresh your screen unless and until it is very, very important. All right, we will be, starting with the quiz in 1 minute, 1 to 2 minutes. For those who are new to this quiz, when the quiz starts, that is after I'm done with my briefing and the quiz starts, a question will appear on your screen. You'll be given 30 seconds to answer the correct question, to choose the correct answer, and you'll be given four options, and you will be able to see the after the time passes, you'll be able to see the correct answer and explanation for the same. All right, we'll be starting with the quiz. Do share this quiz link with your friends, as this is a wonderful opportunity for learning and winning prizes. All right, so let's start with the quiz. The first question will soon be on your screen. Okay, so the time is up. You can see the correct answer on your screen. You can refer to the explanation for the same. Moving on to the second question. The time is up. And the correct answer to this question was canaries, early adopters, and users. You can refer to the explanation seen on the screen. And 50% of the participants answered it correctly. Moving on to the third question. The time is up. And the correct answer was continuous integration. Around 47% of you answered it correctly. Let's go to the fourth question now. The time is up. And the correct answer to this question was allows exclusive file locking. You can refer to the explanation seen on the screen. Moving on to the fifth question. The time is up. You can refer to the correct answer and explanation seen on your screen. Moving on to the sixth question now. The time is up. And the correct answer to this question was automatically ensure you don't skip broken code. You can refer to the explanation seen on your screen. Moving on to the seventh question. The time is up. And the correct answer to this question was stage. Moving on to the eighth question. The time is up. And the correct answer to this question was brownfield project. You can refer to the explanation on your screen. Moving on to the ninth question now. The time is up. And the correct answer to this question was create a pull request to merge your new branch into the main branch. Let's go to the 10th question now. The time is up. And the correct answer to this question was shift left, automation, and continuous improvement. You can refer to the explanation seen on your screen. Around 38% of you answered it correctly. So just three questions to go, guys. All the best. Moving on to the 11th question. The time is up. And the correct answer to this question was infrastructure as code. You can refer to the explanation on your screen. Moving on to the second last question of this quiz. It will soon be on your screen. The time is up, and you can see the correct answer and explanation on your screen. Let's go to the last question. All the best, everyone. The time is up. The correct answer to this question was commit personal and secure files. With this, we have come to an end with this quiz, and the top 5 people who top the quiz leaderboard will be given vouchers worth 200 rupees. All the winners of this quiz will be reached out to through email soon, and like this will be having our next meetup in this month, so stay tuned. You can follow our social handles to be updated with the upcoming events. You can find them in the description of this YouTube video. And with that, thank you everyone for joining this meetup and this quiz, and have a nice day ahead.